Hello there dear, I have been looking through some of the colour of ions activity sheets that have been handed in, and in response to those and some of the comments I've been seeing on the general page, I thought it would be a good idea to produce a little help guide for tackling this activity. Now it is tough and it can be a little complicated to wrap your head around, so that's what I'm here for. Let's get stuck in. So, the colour of ions activity asked you to use the information sheet to work out the colour of ions in each compound. Now, when we're talking about ion colour in this sense, we mean the colour of the compound as you see it. It is different from flame colour, and that flame colour is the colour that an ion produces when it's burned. So if you were to hold potassium hydroxide, for example, over a Bunsen burner, you would see a lilac flame because that's the colour the potassium ion produces when it is burnt. What we are looking at today in our colour of ions activity is just the visible colour you can see. So, you are given a table like this and you are given a help sheet, which I'm going to pull some of the images from in just a second. But every compound on this list, if I bring my mouse in, all of these compounds are ionic compounds. And ionic compounds are made of positive metal ions and negative non-metal ions. So when we are filling in this table, our positive ion will be our metal. For sodium chloride, our positive ion is going to be sodium, because that's our metal, and our negative ion will be the chloride ion. It's our non-metal, it is negative. Okay, so let's start with sodium chloride. Now, table salt is something that we are all pretty familiar with and have come into contact with in day-to-day life. Now, it's a white solid, and I might call it colourless, because it's white, it doesn't really have a colour. So what does that tell us about the sodium ion and the chloride ions? Well, it actually tells us a few things. So here I have sodium chloride again in the top corner, just to remind us. It is a colourless solid, so it's colourless. Our positive ion is our metal ion, sodium, and its colour is, well, colourless. Our negative ion is our chloride ion, and it too is colourless. So on our colour of ions display, there are another two colourless compounds, potassium sulfate and sodium nitrate. Now, just with sodium chloride, if the whole compound is colourless, that means that the ions that make up the compound are also colourless. So, potassium sulfate is this one here. It is colourless, so colourless, which means that the potassium ion, which is our metal ion, I apologise for the writing here, guys. The potassium ion is also colourless, as is our negative sulfate ion. Now, I'm going to spell sulfate with an F because that is the correct spelling of it. It changed a little while ago. It was PH, it is now back to F spelling. If anyone was wondering why it's PH here and F here. That is also colourless. The same rule then for sodium nitrate, it is also colourless. So our metal positive ion is sodium, it is colourless, and our nitrate ion is our non-metal. Now, nitrate is made up of nitrogen and oxygen, two non-metals, and it is also colourless. So let's look at something that is slightly more interesting. I have copper chloride, copper sulfate and copper nitrate. Now, unlike sodium chloride, potassium sulfate and sodium nitrate, these all have colour. They are all blue. So copper chloride, copper sulfate and copper nitrate are all blue. But we know already that the chloride ion, the sulfate ion and the nitrate ion are all colourless. It doesn't matter which compound they are in, they are still going to be colourless. So we can copy that in just now. So copper chloride, the chloride ion will be colourless as it was in sodium chloride. The sulfate ion will be colourless. And the nitrate ion will also be colourless again. So that means that the blue colour seen in copper sulfate, copper nitrate and copper chloride comes from our positive copper ion. So our copper ion then will be blue. Now let's do one more just to complete our set. So here on the screens we have nickel nitrate and nickel sulfate. Now these also have colour. They are green. However, we know that the nitrate and sulfate ions that we have come into contact with before are colourless. So our nitrate is colourless. Our sulfate is also colourless. So this green colour that we are seeing must come from our positive nickel ion. So the nickel ion then will be green. Now I have now done slightly over half of these to get you started. If you need any more help, send myself or Mrs. Grimes an email or even post on the S3 team. It's important that if you're struggling, you let us know. And if you would like to have another go at this activity, if you've already handed it in and you realise, oh, I've made a mistake, I know what I'm doing now, then let us know. I'll return it back and you can submit again. Thank you for tuning in again, guys. And if there is anything that we can do to help, please just let us know. Take care. Bye, guys.